been the center of excellence and its graduates the source of it. With their potential and notable contributions all over the world, our next speaker is a GIK alumni who not only holds a PhD in robotics and automation, but also the founder of Automotive design Crashworthiness, Pakistan. He's also a painter, designer, and a member of the music band called Circus. Please, with a big round of applause, welcome Dr.Omer Masood.
Thank you. Thank you for this wonderful opportunity to come here and speak. My name's Omer. I'm a PhD in Automotive Crash-worthiness, and I study accidents. Boring? Yeah. I've built a career around studying accidents. And, well, when we talk of Pakistan, we see traffic as one of the low-down, boring stuff that policemen do. It's nothing to be studied, nothing to be controlled, nothing to be seen. Because obviously, Pakistan has a lot of problems. We have terrorism, we have other problems, we have famine. Does anybody remember APS? What day was it? 16 December, everybody remembers that day. I remember that day because I was there at university and, we were all just stunned. That was 16 December 2016. Everybody was stunned. And we walked out, and what did you guys feel that day? What was the feeling? Anger. What else? Horror, anger, resentment. Everybody had this question, what can I do to stop this from happening again? What could I do? What could my role in the society be? And APS happens every day on Pakistani roads. We had a friend from South Africa, Helen, and we were coming to GIK, and we were having this conversation about how her mother reacted when she decided to come to Pakistan. Yet, only 1,800 people died on terrorist activities in 2016. 35,000 people die in accidents. Our enemy, number one, is traffic accidents. And who are these people? Who are these 35,000 people? They're not old people, they're not rural class people, they're middle class, urban generation, young people, the kind of people the economy needs. And the collective damage of accidents to the Pakistani economy is about 80, 90 billion annually. That's the amount of GDP, that's the amount of funding HEC gets. So all universities combined, the funding the HEC gets is less than what we lose in accidents per year. And we have that because we have a fatalistic attitude. Well, there are accidents. They happen. What can we do about it? And it's for traffic police to control. It's nothing to do with engineers. I'll give you one small example. Can you play this video, Hamza? This vehicle, about 160 kilometers per hour, hits the wall head on. What do you think happened? What do you think happened to the driver? Seriously injured? He died? D. Went partying afterwards. We're in KPK. No, that's not happening. and we know we have Jamilu Nabi as the pro-rector. That's not happening at all. Well, we'll play that video again. You guys can make up your mind. Head on, 150 kilometers, straight, flying into the wall. A? Yes, D. Now the question is, why D? Was it some sort of fate? Was it some sort of miracle, or was it science? It was science. If the same accident was to repeat itself 10 times, the outcome would be exactly the same. Because somebody out there, some designer out there, studied the whole system, and he realized that the human is going to make an error, and there is going to be an accident. And then the whole system design starts after it. This is a subject called vehicle crashworthiness. Vehicle crashworthiness is a very advanced subject, and it's about accepting the fact that humans on the road will make mistakes, they will make errors, but the system design, or the vehicle design in this case, has to forgive that error. There's a post-crash world out there that has to be studied. And crashworthiness believes that every accident repeats itself. Every accident repeats itself again, 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 until the whole system does not correct itself. I was part of the inquiry team, the government inquiry team for this accident. I'm sure you all remember this. You must have seen all these videos. Okay. And there were lots of conspiracy theories about it, lots of people coming up with lots of information, lots of viral videos being shared, and everybody wanted to know one thing: what really happened? And when we were called in by the government wanted to know one answer. It said just one answer: whose fault was it? Who do we blame it on? I'll change that question to what have we learned? Okay. And the answer to that, the first question was, well, it is everybody's fault. When an accident occurs, it's a system failure rather than one driver error. What happened on that day was, driver Ghulam, he was alone. He had been driving for 17 hours non-stop, hadn't taken a break because he wanted to get home for Eid. And he stopped for Sehri, and after Sehri he continued. And just for that 2 seconds, he fell asleep on the road, dozed off behind the wheel. He dozed off behind the wheel, the vehicle veered left. He woke up 2 seconds later. He's like, woke up, turned right. And when he did that, the vehicle overturned. Okay. The tank of this vehicle remained intact, almost. Okay. The vehicle was badly designed. It wasn't up to ADCR standards. It was higher than usual. It was bouncier, and the baffle plates weren't working, so the liquid was sloshing right and left. The vehicle overturned because of that. And when the vehicle overturned, the tank remained intact, almost, except for the fact that it wasn't an integrated chassis. And since it wasn't an integrated chassis, the U-bolts opened up, and the tank dismounted from the vehicle itself. That still wasn't bad enough. This was the design of the tank from the inside. There was some bad engineering at play, which had placed 2 stiffeners right here, one on the left, one on the right. One of them punctured through. And that is all that caused the entire disaster. That's all. That's one small pinhole that occurred. At 6:22, there was a fire. The exact reason is still unknown, but it started from the south side and traveled north because people gathered over, and that is 1.5 hours after the accident. This is a picture of the scenes taken by a bystander. But the thing about this is that it's right when the explosion had not occurred. It was before the explosion. Only 50 people or 40 people had died in this accident. And the rest of the village started gathering around. And this tank design did not have a fire engulfment release valve. That's a valve that opens up, releases pressure. And because of this, the tank exploded. And it exploded into something like this. People from the materials department would recognize this picture. That's a hoop stress failure. Builds up because of overpressure inside the tank. And hoop stress failure occurred, and the whole tank exploded onto the village. 200 people dead. So my question to you guys would be, what could technology or what could engineering do to save this? And what could you do as part of the society, as part of people who are looking for jobs, who are trying to build up their setup, who are trying to do something? What could you do to prevent this from happening? If there was technology, there's a small, very small technological device called a fatigue alarm. You close your eyes for 3 seconds, it starts beeping. Had that been in place, the driver would not have slept. Had there been 2 drivers, automotive regulations there, the driver would have been woken up. And even if the driver had slept and lost control, had there been a proper ABS system installed, the vehicle would not have overturned. And even if the vehicle had overturned, it would not have leaked. And even if the tanker had leaked and the police enforcement had proper SOPs, the crowd would have been dispersed. And even after that, even if it had caught fire, it would not have exploded. Only 50 people would have died. That's the role technology plays in accidents. And that's the role engineers should play towards the society. Okay? We only hear about major accidents. But let me show you some accidents you didn't hear about. In 1999, when the first Agra standardized tanker set foot in Pakistan, there was a mob, tanker mafia. They set the tank on fire. There were 25 kl of fuel inside this tank. And because it had a fire engulfment release valve, the inside of the tank remained intact. Nothing happened. Okay. There was this accident. Such accidents happen every day. And this was an oil tanker owned by Total, overturned near Sahiwal, and there was absolutely no leakage. You just flipped it over, flipped on. That's what technology does, and that's what technology should do. Okay. I started work in Pakistan in 2012. I was in Italy back then working for a car company, and one of my students, ex-students, he messaged me and he said, well, this accident occurred and we have to study this. And I said, okay, it's very exciting. It was the first job I took for the government. And we started studying this accident. Do you remember this accident? Anybody? Karar Kahar, 2011, 33 people dead, 33 school children dead. Yes, it was a very famous accident at that time. And this guy called Zishan, he spent a year studying this accident. He took this as an FIP, took this as a passion project, and he started studying the accident in detail, every single detail. And he went to Lahore, collected samples, made a material model, modeled the entire bus, flipped it over, and he found out that there's this regulation that says that if a vehicle overturns, it has to sustain 4 times its own weight. That's called ECER 66. We do not have a regulation in Pakistan. We do not have any vehicle safety laws in Pakistan. And that is why accidents such as these are occurring again, again, and again. And history repeats itself every day on Pakistani roads, just because the engineering is not at par. So he struggled for a regulation. He went to, the IG police. He went to the secretary at that time. He went to the minister. Everybody liked the idea. No regulation was passed. A year later, he left for the University of Michigan. That was the end of the story. Okay. In fact, when we started studying the area, what we found out in Kalar Kahar, that same point was, the same point where 97 accidents had occurred. And we took data from Motorway police, and they had data in this form. This was a map format. And we started reinvestigating all accidents that had occurred during that time. And what we found out was amazing. These are the telephone poles. 224 is the telephone pole number. And, this marks the kilometer range. And when we collected accident data, it was so surprising because on the north, when you climb up the mountain, There were some peaks, but coming down from the mountain, there were only these 2 points which stood out. And the biggest fact was when we started looking at pictures of these accidents. This is in 2013, this is in 2016. History repeating itself because nobody had studied these accidents. The same accident happening again, 17 times in 19 years. 77 times in 19 years. And it was happening because the road surfaces were different, the friction coefficient was different, but the irony of the fact is that nobody studied it. And the irony of the fact is, even after this report came out, the problem is still there on the motorway. The same thing is happening again and again. And there were startling other facts. I mean, for example, 40% of the accidents were occurring at night when there were, there's 5% of the traffic. And there was this other very, very amazing accident. Because when you talk of modern cars, they have all these technologies, the seat belt, the airbags, crumple zones. Mehran doesn't have it, but all other cars have crumple zones, so they kind of absorb energy. And you have a safety steering wheel, a safety cage. You have 100 features that, that save people from accidents in a crash. But when you crash with a truck, this is what happens. Absolutely no chance of survival. And the irony is that it's a very easy engineering solution that could save this. In fact, in this data, we found out that 54% of deaths on the motorway were occurring just because of this one small engineering device called the underride guard. That wasn't there. Okay. And then again, we've been studying guardrails as well. This is how a guardrail should function. Deflect the vehicle back on the road, no damage done, do not absorb any energy. And this is how guardrails in Pakistan work. Complete disaster. Because this barrier is a very old design, was designed in 1960s, has not been changed. And even roads being built today in Pakistan employ the same New Jersey barrier as part of the design. I remember this accident. It killed 3 people because the container flipped over, went on the north side of the road, and there was a city coming and just crushed it off. Okay. There was this other accident we studied for the government, had an inquiry. All these inquiries are present on my website. You can go and look at them. 60 people died in this bus. It collided with a tanker. But technology could have saved them. What technology would I be talking about here? An emergency door at the back. That's it. Okay. That's the kind of regulations we need in Pakistan. And there was this accident in 2014, 57 people died. And again, the government wanted to know the same question, whose fault is it? And we said, well, this is history repeating itself. Bad roof design, crumpled, killed 57 people. We have investigated these accidents and yet we're yet to formalize a solution. So the second part of our consultancy was to make rules, to make regulations for the government. And we started making regulations. One of our biggest hurdles was, where do we start in Pakistan? Where do we put our first regulation in? And before we could even put in all these regulations that you can see here, we didn't even have a vehicle classification code. We didn't even know what kind of vehicles are on Pakistani roads. And then we had things like this, which were 130 feet long on the highway with no regulations at all. And then if you look at the future, we look at CPEC, this is what we're looking at. I saw this being sold on Alibaba a few weeks ago. This is what the future of Pakistani roads will be if we do not have laws, if we do not have standards. and if we do not have engineers who are contributing to the field of vehicle safety. And then there are bad things on the road, seriously bad things on the road. Okay. So this is a project we did for the National Highway Authority, and what we did was we designed a complete vehicle classification code of Pakistan. And we classified every vehicle into its categories. Then we had this definition, technical definition of every kind of vehicle in Pakistan. Yeah. And after that, after we did that, we had the first vehicle dimensional rules of Pakistan. 2 years later, we made the first law in Pakistan, which was known as the Pakistan Vehicle Dimensional Rules. And this was done after 1969. Pakistan Motor Vehicle Rules is 50 years old. And after 50 years, we made the first laws in Pakistan. And what we're looking for is more work. Okay. We've still got a long way to go, still got, got a huge problem, and it's just the tip of the iceberg that we've sort of touched. But as engineers and as people who are looking out to explore the world, I'd really love to, excite you about vehicle crashworthiness, and I'm sure you'd all be making your career choices. But then again, at the end of the road, it doesn't matter how much money you make. Like the speaker before me pointed out, at the end of the day, it does not matter what rank you retire on. What matters is what you've given your country back and what you've done for humanity. You can make money selling cigarettes, you can make money working for, okay. You can make money working for multinationals, and you can yet make money, and a lot of it, by providing innovative solutions which are in line with humanity. Thank you very much. It was a wonderful session. Thank you.